Odd and even functions and graphing with the TI84. So determining if a polynomial function is either odd or even, it depends on the way it is reflected. And so we're going to be dealing with function notation. And so the rule to determine if it's an even function is the original function has to equal f of negative x. What that means is we're going to replace all x's with negative x and simplify. If it's as same as the original, it's even. On the other hand, an odd function is defined as f of negative x is equal to the negative of the original function. So in this case, we're going to replace all the x's with negative x, and if it's the same as negating the entire function, then we say that it's odd. Now, not every function is odd or even. Sometimes you can have neither. If you check both of these rules and neither of them are true, that means you have a neither function. Even functions generally take the shape of a quartic. The end behavior goes upwards on both or downwards on both ends. The odd functions generally take the left on the top and the bottom on the right. What we're going to do is we're going to determine if each of the following functions is an odd function, even function, or neither. So number one, we're going to see if this is odd, even, or neither. So we're going to check the two rules. Now, if you look at the rules, let's think about this in a strategic way. On both rules, you need f of negative x. So the first thing I always check for is if it's an even function, because I have to have negative or f of negative x. So we're going to first check and see if it's even. So the first thing we're going to do is check for even. Check if even. And we do that by saying the original function equal to f of negative x. So let's figure out what f of negative x is. So we're going to replace all of our x's with negative x. So instead of x to the third, we will have negative x to the third minus 7 times negative x. Well, negative x to the third is really negative x times negative x times negative x. So this ends up being negative x to the third without parentheses because you're doing negative x times negative x times negative x. Negative 1 times negative 1 is positive 1, times another negative 1 results in the negative in the front. And then x times x times x makes x to the third. So we did simplify negative x to the third. It just ended up being exactly the same thing as it was originally. Now, negative 7 times negative x is a positive 7x. So now we need to see, is this equal to the original function that we had, x to the third minus 7x? Well, in this case, it is not. So that means this function is not even. Well, now we need to check and see if it's odd. So to check if it's odd, we need to see is f of negative x, which we found just a minute ago up here, the same as negative of the entire function. So we have this one already. We have this guy. That's the negative x plus 7x from the top. We need this one. So let's figure out what negative f of x actually is. So this means we're going to put a negative around the entire original function and see if we end up with the same thing we had above. So let's distribute, and negative times x to the third is negative x to the third. Negative x times a negative 7x is positive 7x. So we have now determined what negative f of x is. So we're going to see, is this equal to f of negative x, which was this from earlier, negative x to the third plus 7x. And we do, in fact, have a true statement. This is the same as this one. So that means your function is odd. We checked if it was even, and we didn't get something that was the same. We checked if it was odd, and we got something on the left and the right that was equal to each other. Now let's look at number 2. Let's try this one. F of x equals negative x squared plus 5. So again, I want to start by checking if it's even. Checking if even. And so that means the original function should be equal to f of negative x. So let's find f of negative x. So that would be negative of x is being replaced with negative x squared plus 5. So let's take this in pieces. So negative of, well, negative x and I square it is actually just positive x squared, because again, you're taking negative x times itself. Negative times a negative makes a positive, and then x times x makes x squared, plus 5. Then negative times x squared is again negative x squared. So we got kind of back where we started. So this is f of negative x. So now we need to see, is that equal to the original function? Well, the original function is negative x squared plus 5. So these two are in fact the same, so we can say that yes, this function is even. And we can stop there. Since the even gave us a true statement, the left equal to the right, we don't need to check if it's odd. This is an even function. Now let's look at example 3. F of x equals x to the fourth minus 5x to the third. So again, we're going to start off by checking if it's even. And we do that by seeing if the original function is the same as replacing x with a negative x. So let's see, f of negative x will be x to the fourth, but x is now a negative x to the fourth, minus 5 times x to the third is a negative x to the third. And now we simplify. Negative x to the fourth becomes a positive x to the fourth, because a negative to the fourth power leaves me with positive x to the fourth. Now we have minus 5 times negative x to the third. Well, again, negative x times negative x times negative x. Negative times a negative times a negative makes a negative. X times x makes x to the third. Then we can distribute. So we get x to the fourth plus 5x to the third. Now we need to see, is that equal to the original function, x to the fourth minus 5x to the third? And it is not. One's a plus, one's a minus. So that means this is not even. So now the second thing we need to check is, let's check and see if it's odd. And to check and see if it's odd, we have f of negative x being equal to the negative of the entire function. But again, we did this part already here. So we've done that. We need to figure out this one. So negative of the entire function will be negative of x to the fourth minus 5x to the third. So this negative will be distributed, so we get negative x to the fourth. Negative times a negative is a positive 5x to the third. We need to see if that is equal to f of negative x, which we found up here on the even, x to the fourth plus 5x to the third. And we see that these are not equal either. This is the same now, but this front one is not. And so that means it's not odd. Well, if it's not even and it's not odd, that means it has to be neither. So if you check the even and it turns out to be not even, you check odd, turns out to be not odd, that means it has to be neither odd or even. There's no other option. So I'd like you to pause the video and I'd like you to try the next two examples, 4 and 5, on your own. Here's what you should have had for examples 4 and 5. Now let's look at determining attributes using the graphing calculator. So not everything is going to give us a graph already, and sometimes we need exact coordinates for max and min, so a sketch isn't going to work. So here are a lot of steps on how to use your TI84 graphing calculator. I'm not going to read these to you. You can pause the video and take a picture, but we're just going to go through these steps on our own. So for 6 and 7, we're going to determine a few attributes, and then we're going to sketch a graph that shows up on our calculator just so we have it for our notes later. So number 6, determine the following attributes for the function g of x equals x to the third plus 3x squared minus 14x minus 20. Well, step 1 would be actually typing this into your calculator. So take a minute and open up your TI84 calculator. So once you have your calculator open, you're going to press y equals to graph, and you're going to graph in this polynomial. So we have x. So we have the x key here. Now, to the third power, there's not a quick key for us. We need to use our little caret to get an exponent. So caret 3, and then make sure you move your right arrow out of the exponent to continue typing. Plus 3x, and you can do the up arrow again, or you can use the quick key for squared here. And notice it already puts you out of the exponent if you use the quick key. So squared has a quick key. All the other exponents need the up arrow caret key. Then we have minus, make sure you're using a minus and not a negative. 14x minus 20. Minus 20. When you're done, press enter, and we can graph. So once the equation is typed in, you're going to press the graph key, and you should be able to see most of it. Now, I do need to see max and min. So what I'm going to do is I'm going to zoom out just a little bit. So we're going to press zoom. We're going to move down to zoom out, press enter to select zoom out, and press enter one more time to actually do the zoom out function. And now I can see everything. Here's my max, here's my min, and I can also see the end behavior left and up. So for the domain, off of my graph, the domain is very simple. The furthest left is negative infinity, the furthest right is infinity. Range is also negative infinity to infinity. Now, finding our zeros. So remember that zeros are x-intercepts. So we're going to use this one key quite a bit. We're going to use this calculate. So it's the blue that I need to activate. So I need to press the second and then trace in order to get the calculate menu. Now notice there are lots of options here. Well, the first thing it asks us for is a 0. So go to selection 2 and press enter. Now it asks you left bound and right bound. You need this little blinking cursor to the left of your first 0. So I'm going to use my arrow keys and move it to the left of my first 0. So here's the x-intercept, and left is over here, right is up top in this case. So we're going to press enter because we're now on the left, and now it asks for right bound. So I'm going to use my arrow key and get to the right of my 0 and press enter. And then it asks you to guess where the 0 actually is. Press enter. So there's my first x-intercept at -5, 0. Then we do the process again for the second x-intercept. So we're going to do second, trace, arrow key down to 0 and press enter. And then we do it again, left bound. But now I want to be left of this 0 here. So left of this 0 is actually at the top. So I am left bound, so we're going to press enter. Now it says right, so I'm going to go to the right of the 0. So this is to the right because this is the x-intercept that I want. Enter. And we're going to guess again. Enter. So this x-intercept is a decimal. Round it to about 2 decimal places. So -1.24, 0. And then we do it again for the third one. So second, trace, 0, enter. And again, left bound. I'm going to go right about, that's too far. Here's the left, because remember, this is the 0, so the left of that would be underneath. So enter. Right bound is up above, enter, and guess. So this is also a decimal. 3.24, 0. Round to 2 decimal places. So you have found all the zeros of your function. Now let's look for maximum and minimum points. These are our turning points. So my max is here, and my minimum is here. So let's see. We're going to do second, calculate again, and then look, there's min and max, 2 options. So let's find the minimum. Well, letter D asks for max, so let's do maximum first. And it's going to ask you the same questions, left bound and right bound. So here's the max. I need my little blinking cursor on the left side of that turning point, which would be somewhere over here. You can even have it way down there, doesn't matter. Left side of the turning point. Press enter. Now it asks you to go on the right side of the turning point. And so this is the right side. Enter. And ask it to guess where the maximum is. So here's our maximum point at -3.38, 22.98. There's the max. Now let's look at the minimum. So again, second, trace, go to minimum, and it's going to ask you the same 2 questions, left bound and right bound. So here's the minimum point. We need to be on the left of it. So this is the left somewhere. Enter. Now go to the right of the minimum. Enter. And guess. So here's our minimum coordinate. 1.38, -30.98. Okay. Now, everything else we can get from our sketch because the sketch is a tad bit easier to work with. So before I do FG, let's do H. Let's make a sketch of this graph. So Let's start with my zeros. I have a 0 at -5, so somewhere over here at -5, -5. Then I have another 0 at -1.24. Then I've got another 0 at 3.24. My maximum coordinate is -3.38, somewhere around here, and then 22 something, so way up here. So -3.38, comma 22.98. And I'm going to label here because you'll see why in just a moment. And then our minimum point is 1.38 and -30 something. So somewhere around here. 1.38, -30.98. Remember, it's a sketch. It's not an actual graph. And so the function itself, according to my picture, starts at the bottom left. So I'm going to go like this, hit my max, turn back around at this 0 that I forgot to actually put a point on, that 0 here. Turn back around, go through this 0, hit the minimum point, and back up through the other 0, like so. So for increasing and decreasing intervals, my increasing interval, remember that's where your y values are going upwards. So that would be here and here are my increasing intervals. So I start increasing at an x value of -infinity. I stop increasing when I hit this maximum point here at -3.38. That's why the labels are nice. Then I continue to increase when I hit the x value of 1.38 all the way up to infinity. The decreasing interval is where your function is going down. That's this middle section for this example. And so I start to decrease at an x value of -3.38. This maximum point is where I begin to decrease. And I keep decreasing until I hit the minimum point at 1.38. And that is the only decreasing interval that I have for this function. So what you really need your calculator for is the zeros, max and mins, and that's really it. Domain and range is nice because you have a picture in front of you. But C, D, and E are the places that you really need your calculator for. Now, if you were to find the y-intercept, it doesn't actually ask you for it, but let's go ahead and find it out anyway. So to find the y-intercept on your calculator, you're going to do second and calculate or trace, second, trace, but you're going to look for a value. Because if you notice, there's not anything on here that actually says y-intercept. So we're going to look for a value. That means you're looking for a point. So press enter. And it's going to ask you, which x do you want? Well, think about a y-intercept. Your x is always 0 no matter what. So we want to calculate an x value of 0. So we're going to put 0, and we're going to press enter. And it gives you the y-intercept at 0, -20. So this point here should be 0, -20. So you can find exact points on this graph using the value function. I'd like you to pause the video and try example 7. If you need to, go back and look at these steps for the calculator. So pause the video, try example 7. And here's what you should have had for example 7. So you may have seen something like this that showed up on your calculator when you tried to do the minimum point or one of the zeros. Remember that this is really scientific notation. E to the -6 means you're going to move the decimal place 6 times to the left. Well, if I move this decimal place 6 times to the left, all of these get filled in with 0. So what this number is this number is basically 0. The problem is this calculator is pixelated. So what's happening is the pixels are not accurate enough to get a precise number of 0, so it thinks it is off just a little bit. So if you have some number like this and an e to the -8, -10, -14, any of those things, that's a number that it's 0. It's just having a problem actually calculating the 0 because the pixels are not quite very accurate. So do keep this in mind when you see something like this.